Hi guys, welcome to today's lesson. So today we're going to be focusing on changing parameters of functions, right? What this means is the transformation of functions, maybe shifting a graph to the left, to the right, shifting it up, down, reflecting it about a certain axis, maybe the x-axis or the y-axis. That's really mainly what I'm going to talk about. But before that, we just need to look at a quick recap of big ideas that we need to look at under this particular topic. So let's just jump right into it. Now remember that with functions there are different types of them, which is linear, quadratic, hyperbolic, and the exponential one. So there's what we call the notation of a function, which we just quickly gonna look at what exactly it means, and then the definition of what a domain and a range is. Now, those will be our keywords, which is the function notation, the domain, and the range. Remember that when we talk about function notation, it's normally what we use in order to represent an equation of a function instead of using y when writing the equation of a function, right? So for example, I would then say f of x is equals to x squared instead of saying y is equals to x squared. And the main reason for using this f of x and the g of x and the h of x is because at times on the same system of axes, you will be required to draw many graphs. Now, if you're drawing many different graphs on one set of axes, you can't call them y is equals to y is equals to y is equals to. Then there won't be any distinction between which function is which. So if I have 3, then I can say the other one is f of x, the other one is g of x, and then the other one is h of x. Then I know for a fact that I'm talking about 3 different graphs that are drawn on the same system of axes. So please do understand, that's the main purpose of function notation, so that there's not that much ambiguity with which function am I focusing on. Also, the domain of a function will be the set of all the input values for which the function is defined, right? When I talk about the function being defined, it means where the function can go, where it can cross, where it can intersect. And then the variable that is represented or that is representing the input values is normally referred to as the independent variable, which is normally on the x-axis, right? And then when we talk about the range of a function, this will be the set of all the output values that result from the input values. Because remember, input will be the independent variable. Therefore, this one will be called a dependent variable, and it's normally on the y-axis on the Cartesian plane. Now, in specific, to look at the changing of parameters, we're going to focus mainly on the quadratic function, which is normally called a parabola. So remember that a quadratic function is a function of the form f of x is equals to ax squared plus bx plus c, where the a, the b, and the c are constants, right? They can be any real number that is there in mathematics. They don't represent anything specific. And then the graph of a quadratic function is normally called a parabola. Also, the quadratic function can also be in the form f of x is equals to a open bracket x plus p all squared plus q, right? Where the p and the q are the coordinates of the turning point. So in simple terms, if you know what your turning point is, your very first thought will be to look at this particular equation in order to maybe find the equation of that particular graph, or to then actually tell what the turning point of the graph is. But with the other one, it will be mainly when we want to talk about the root, which are the x-intercepts, which I believe by now you do know that x-intercepts will mean we must let y be equal to 0. And then we can solve for x from there. So that's what this is all about. So this is the other type of a quadratic equation that we can use to represent a parabola, given that we know what its turning point is. Now, the value of a in the equation, because we still need to know what exactly this a tells us, right? The others are constants, yes. Even a is a constant, but it tells us what the orientation of the graph is, and it also tells us the closeness of the arms of the parabola to the y-axis. In actuality, it means that if my a is greater than 0, meaning it's positive, right? Therefore, the parabola will then be concave up, which we use a happy face as a representation, or rather as an explanation of what this is, because it is looking like a happy face, a smile. And then when a is less than 0, the parabola will be concave down, which then means it's a sad face. So just so that you can remember what it looks like. Remember, I said again, it also talks about how close it is to the y-axis. So the greater the value of a, the narrower the graph becomes. In simple terms, the more close it gets to the y-axis. Just to show you what this means, if maybe my graph is y is equals to x squared, it will look like this, and then it becomes 2x squared, and then it becomes 3x squared. So as a is increasing, it means that the graph will become a bit narrower in terms of the distance from the y-axis. Just so that we can look at a specific question now of this, how do we change these parameters? The first question will want us to draw a graph of f of x is equals to x squared. And then we'll go down with the questions to see what it will end up as at the end. To draw the graph, remember that the very first thing to always try and do is to find the table of values, right? Where you choose your own inputs. But the inputs, if you take from -2, you can take up until +2, and then find the output values using the equation f of x is equals to x squared. And then after drawing the graph, it will therefore look like a happy face number 1, because the value of a is equals to 1, and that's a positive, so it must be concave up. And then because it is x squared, it means all the output values will definitely be positive. We then need to reflect this about the x-axis, and to do that, it means that because the function was f of x is equals to x squared, when I reflect this about the x-axis, it will be minus f of x is equals to x squared, which eventually becomes f of x is equals to negative x squared. So in simple terms, it now becomes a sad face instead of the happy face. And therefore, the graph will look like this. And then you will also need to shift the graph 1 unit left and 3 units up. So just to go back to what we had, right? Remember that the graph was turning at 0 and 0. Firstly, you shift it 1 unit to the left. So it means it will now be turning at -1 and 0. And then after doing that, you shift it 3 units up. So it will be at -1 and 3. Therefore, my turning point will be at that point there. Now, they will also want us to write the equation of the new function. To do that, you need to look at how did we form g of x. We formed g of x by reflecting the graph of f about the x-axis, which made it to be negative x squared. And then from there we shifted it 1 unit left, and shifting it 1 unit left will make it negative x plus 1 all squared, and then we shifted this 3 units up, which will mean it will be plus 3. Now I know some people are going to wonder why is it plus 1 and not -1, because to the left is minus. But it simply means that it's y is equals to -1, right? Because x is equals to -1, that's where it lands. So the new turning point will be x equals to minus 1. If I want to write it as x plus p, it will be x. Then the minus 1 is taken to the other side, therefore it becomes plus 1 equal to 0. That's where the plus 1 comes from. And therefore, my equation will then be g of x is equals to minus into x plus 1 all squared plus 3. Just to summarize what we know about these two functions, the value of a for f of x was 1, and the value of a for g of x is now minus 1, right? Because it was reflected about the x-axis. The turning point was at 0 and 0 for the graph of f of x, and now for the graph of g of x, it was moved 1 unit to the left, so the x value is now minus 1, and it was shifted 3 units up, so the y value is now positive 3. And the domain is x is an element of real numbers because it can be any number because of the squared, and it does not change even with the g of x. But what changes is the range. Here with this graph, remember it was above the x-axis, so it means all the y values are positive, and this one will then be less than 3 because that's where it will be tending to face down. So that's what you need to look at. When you are shifting a graph, you just need to look at what will be the new value. That's what will inform you to write the new formula. Guys, I hope you're having so much fun, but for now, I want us to take a quick ad break and we'll come back with some more work to do. Please stay tuned.